Hey guys, this is Surya from Skill-Lync. Hope you're doing well. This is another interesting video that I've always wanted to do. I'm happy that I'm doing it right now. As you all know, for students who take our premium master courses, they also get an opportunity to intern with a subject matter expert. Last week, I spoke about the CFD internships and the different types of projects you can work and the experts that you will be working with. So Saran came into that video and also explained the different types of projects. If you have not taken a look at that video, the video's link is below in this description. Do take a look at it. So this week, I wanted to also speak about the design aspect of it. So last week was CFD, this week was design. In this video, I'm going to speak about what kind of internship that you will be working on if you enroll in a design master's coursework, or if you're picking hybrid electric vehicles and specializing in design, right? There are different design master coursework. If you enroll in any of these design master coursework or the design aspect of hybrid electric vehicles, you can end up working on these design projects. So to speak about design, I have someone very special. I've known him for the last 3 years, and he is an expert in automotive design, especially in body in white. So he is Subramaniam Janakiraman. He currently works at Scania in Sweden. And before Scania, he worked for around 6 years in Mercedes-Benz and around 3 to 4 years in Nissan before that. I'll kind of have him give an introduction about himself. And in this video, we are going to look at something pretty cool. We are developing a full-fledged car, SUV, and you will be the guys who will be designing. In the first part of the internships that our students did, we have already designed the BIW aspect of it, and that's what we are going to speak about in this video. I have Subbu already in the call, so I'll basically have him also. Subbu, how are you?
Hello Surya, I'm fine, and how are you going there?
I'm doing good, Subbu. Thanks for taking time and coming today. Subbu, can you just give a small introduction about yourself?
I am Subramanian. I've been working now for Scania in Sweden as a supply quality manager, and I have around 14-15 years of experience in the automotive industry, where I started with Nissan and then to Mercedes-Benz and now in Scania. So I've been working with BIW on plastic parts right now. So I've been expertised with BIW, and I've been associated with Skill-Lync since its inception, I could say, for around 3-4 years now. And I had developed this BIW course and courses related to BIW. And now we had this interesting opportunity of developing a complete vehicle starting from the scratch, where we developed our own styling, which is an SUV, and then we developed the BIW of it. I would like to take you through the components, what we have designed and what we have yet to design. So we have a beautiful internship opportunity here. Let us go through the presentation, if it is okay for you, Surya.
Yes, Subbu. So, Subbu, before getting into the presentation, I wanted to also ask a few things. So, as you know, we have multiple design master courses, masters in design, masters in automotive plastics, masters in BIW fixture design, and so on. And during this internship, what do students work on, right? In this, say, 3 months, and it's a paid internship, right? What do students work on, and what do they get out of this internship?
I have planned in such a way that this project completes in the March 31st, 2021. So which means if at all the project starts in 1st of December, it is 4 months of duration. And in this time, we have the BIW, which is already developed and which is a rank 5 data. And parallelly, the BIW data will be developed to rank 1. And the intern students who are going to participate in this project, they'll be developing the interior and exterior plastics, the seating design, the harness design, and the lighting design. So these 4 components, when it is getting added to the BIW, what we already have, a complete car without the powertrain and chassis is ready. So powertrain and chassis becomes a different commodity. That would be a different stage of project, which we will do after we complete this project. So at this point of time, the students who will be chosen as interns for our project would have the opportunity to work on BIW improvement of the data from rank 5 to rank 1. Also interior and exterior plastics. When I say interior exterior plastics, I mean bumpers from exteriors and interior door trims and headliners. And then harness design for the complete car and seating design for the complete car again. And lighting design. When I say lighting, it is again front lighting and rear lighting, which includes the complete module. Now, when I say lighting, it is not only the headlamps, it is the indicators, fog lamps, etc. etc.
Great.
So this is going to be the opportunity for the interns now. Yeah.
Great, Subbu. Subbu, just to kind of understand the, in my screen, I see a car, SUV, and these this particular car. Who designed this?
Okay. So this is the car which we designed ourselves. We had 4 interns working for the past 4 months from from July till this day, and we had our interns and we developed our own styling and we developed all the components what you can see here. And we had scratch, we had zero with us, and we sat together. We developed the styling for the car, and then we developed all the interior panels. You could see there is a roof, there is hood inner panels, there are floors, side door inner panels, and body side inner panels. I can maybe show in the next window like what all commodities we had designed in the past
Sure.
3 to 4 months.
If you can show the 3D model, that would be also helpful.
Yeah, of course. So this is where we started, and this is the styling what we have in our car, and this is the first thing what we designed, and later we designed all the rest of the components. For example, from the back door, body side inner panels, left side and right side, body side outer panels, dash complete, and this is the side doors. You have your back door, body side complete, and we also have the floor structures, the engine compartment structure. I can maybe hide.
This is great.
Yeah, so you have your floor structure here. You also have your engine compartment. This is the complete engine compartment. And these are all the floor structures, front and rear floor. And you have your side doors, front, LH, RH, rear LH, RH. And this is again not the only single part. So side door has other inside commodities, inner panels, inner panel, and it has a door beam. It also has a belt line reinforcement. So it is as detailed as possible, like we see on an OEM industry. So if you have a possibility to tear down an SUV right today, you will see all these parts. Minimum of these parts you will definitely see. There are chances that they have omitted some parts because of the cost of the vehicle, or there are chances that they have also added some more parts to the BIW, what you see here, because again to the exclusivity of the project. But when you design a BIW of the car, these are all the minimum most required components what you need to complete your BIW package. When I say complete your BIW package, this BIW is what will be the sturdiest BIW, and this also talks about the rigidity of the complete vehicle, right? So I can also show you the bodies.
I had a quick question, Subbu.
Yeah.
So usually, say for example, I'll take you as an example, right?
Yeah.
When did you learn all of these things?
That is a good question. I started in the year 2008, I believe, and I was a GET by then. And when I started work, the time when I started getting involved myself into a project, it was already 2010. And when I initially started working, I wasn't given any complex commodities. I was just given parts to modify or so add holes or add fillets and radiuses. So by the time I started working on real-time projects, it was already 4 years for me to take up any project like this and to start working on the project.
And
so I think it was 2012 when I started working on full-time projects and full-time activities, because this is how an OEM thinks, sir. When you get into an industry, they wanted you to already start giving output. I didn't have any previous exposure, so they wanted me to first get trained myself so that I can get involved in a project. There were parallelly people with 1 or 2 years of experience who already got involved in the project directly because they had the exposure to the tool, they had the exposure to the components. Now, and that is why we created this kind of internship programs where we already give them an exposure. So once they are into company, they can already start working for the project, or they can at least portray or express their skills to the company, so the company takes them really quick and they adopt them already to the project so soon.
Let me ask you a question, Subbu, just to kind of make sure our audiences understand, right?
Yeah.
So the view that I am seeing right now is the side door body panel.
Yes, it's the body side. Yes.
Yeah. And so I see so for some people, they might understand the terms, which is basically, what do you call those items? So pillars, they call it A pillar, B pillar, C pillar. What do
Yeah.
you, why is that important? What is the engineering behind it? And
Yeah.
when you design this, what do engineers think about? And why is understanding all these things important as an engineer when you go for an interview, or when you basically go into companies like Renault Nissan or MBRDI?
When we first initially start working on the project, we get only the styling. So from the styling, each commodity will have its own purposes for us to design. For example, this is the only part what we will be seeing from outside the vehicle. But this is not going to solve all the purpose. A car is designed to keep the people safer inside, which means that the car can get destroyed, but not the people inside. So all the components what we design are supposed to destroy or dissipate energy outside the vehicle. And that is why we have so many parts outside, and we call them, we segregate these parts into different stages. And this we call it as A pillar lower, A pillar upper, roof rail, center pillar, C pillar, and D pillar. So all these things are on a tubular structure. I can maybe take a section and I can show you. Yes, so now I would like to take a section here and show you what I mean by this tubular structure. Yes. So this is a module. This is a very, very important structure of a body section. For me to understand this structure, it took actually 5 to 6 years. In my career, and that too body side being a very critical component, it took a lot of time for me to understand what they exactly mean. And why is this structure important? This is the place where the body side will first crumple, and the energy which is observed during a collision used to transmit along this tubular area. So the main intention of preparing a BIW is to dissipate energy outside the car and not inside the passenger cabin, because the main purpose of a car is to safeguard the people inside the car and not the car itself. The car can destroy however it wants to, but not the people inside. So the very less possibility for a people to get hurt inside the car during the collision is what should be our design engineer's aim. And these kind of sections are very critical. Say now when I sit for an interview, if there is going to be a person who comes and draws this section to me, I will directly recruit him for the team. Because to understand this section, it takes a lot of energy, it takes a lot of effort, it takes some hours of work. You will have to understand what basic needs you will have to know, and what basic things you will have to understand basic things for you to come and arrive at this kind of sections. And the material, the thicknesses of each commodity, all these things also plays a role. And we as a design engineers, we decide what thickness will work here, what material can we use. And I told this as a rank 5 data because this is not a complete data yet. Now, when all these plastic parts, harness design, seating alignments, all these things come together, you will have to have some mounting holes, mounting embosses, and you can remodify your structures in such a way that they also get mounted there. So it is still rank 5, and you can improve this data to rank 1.
Great. Subbu, this is extremely helpful, because a lot of engineers, say for example me, when I did my engineering, I did not have any clue about any of these things. I just wanted to get into OEMs. I wanted to get into a very good company, but I did not have a understanding of all these things. And one of the things that I'm very happy about running Skill-Lync is the amount of information that is being passed on to students and also people early in their career who want to get into these kind of domains, right? While there is so much that we can basically speak with respect to time, I'm going to kind of ask you for the next steps. Say this is rank 5 data. So the interns who are coming in, what will they do? So can you go to the PPT and explain a little bit about it?
So this is the rank 5 data, what we already have. When I told like rank 5, I already mean that this is not a complete data. Of course, most of the parts are production ready, but not all the parts are production ready, which means we will have to add commodities to it. So what are all the possible commodities which could be added to this is the interior and exterior plastics. So what is this interior and exterior plastics? The doors have their own door trims where you keep your bottle holder, where you have your power window switches, where you have your speakers. So door trim, that is one interior plastic. Similarly, for 4 doors, it is 4 door trims. And for the back door, it will again have another back door trim. Apart from that, interior plastic, you also have a headliner, which is a thermosetting plastic part. And exterior plastics are the front bumper and the rear bumpers. So we have this engine compartment data, we have the bumper reinforcements already available, so you will have to just mount your data. So this is what the interior and exterior plastic peoples will do. We have scope for designing seats, lights, and other add-ons. What do I mean by add-ons? There is going to be room lamps inside the car. So those are again some add-ons. And we also have the scope of developing the complete harness of the car. So the power, the wiring system, which gives power to all the vehicle, that is the harness. So that is still possible. Instrument panel and console, which is going to be a very interesting area again. The complete interior is going to be complete only after an instrument panel and console. So we have a possibility to develop, taking this BIW as an input, we have the possibilities to develop these many items. And if at all it is needed, we can also have students working on the styling, and if it is needed, we can also modify the styling a little bit and then get into and get a real, get the exact input what we actually needed. And this generally happens even in the OEM, when a styling is released, not the styling is completely accepted by the engineering team. They do some engineering study over the styling, and then they say like this styling works and this styling doesn't work. When they say this styling doesn't work, they also give them the feedback that the styling should be modified to this level so that I make the styling workable. And that is what we can do with alias. The engineering people who work on the other commodities might give styling information or styling feedback to the styling person, and he can definitely improve the styling with the requirements what we get from all other people. So this is again an important activity what one can do. And parallelly, the BIW, we will also have to increase from the rank 5 to rank 1. For all the exterior, interior, seats, harness design, instrument panel to get mounted, you need sufficient mounting space on your BIW itself. So to improve the BIW, we again need some people, or we again need some interns to work on it. So my basic idea for this next stage of the project is to develop all other commodities which will get mounted in the BIW, and to also improve the BIW to the rank 1 data, which is production ready data.
Great. I do also, and this is like we require 14 interns that will basically start from December and go till March. For students who are looking at this video, if you're already into some of our design engineering master coursework, and if you finished around three courses in the design engineering masters, you would have gotten an internship opportunity, and you can apply for this. You can get into this project. So for people who are joining us new in the next coming week, we have a few things additional, which is the powertrain, chassis, and in the powertrain we are looking at EV and engine powered powertrain. So designing all those components is the next stage of it. And if you come in, you also have brilliant opportunities to kind of start working on these kind of aspects. So what stage 2, Subbu?
And of course, we will also have the BIW work, which is complete, which is always ongoing on this project. So the people who are in the BIW domain, if you wanted to join this internship, you can also definitely approach us on getting this opportunity. And once all these things is completed, the future scope, which might be the stage 2, is the meshing activity or the simulation related activity. So now, after we complete the plastics and after we complete all the interiors and exteriors, other add-ons, we will have the complete car, and then we try to do part level simulations and assembly level simulations.
Great.
So for example, when you take back door, you might need a torsional simulation or durability check. When you take roof, you will have to simulate the rollover simulations and the snow load. And for the complete vehicle, you have frontal crash, sideward crash, and the rear crash. So like this, you have to do a simulation, you will have to first mesh the commodity. Meshing the commodity itself is a high priority for us actually. And to be really frank, now since I'm in this European Union, I know that how many requirements are there for just doing this meshing opportunity. People outsource meshing projects so much that they cannot handle the intensity what they have. So they just mesh. For just meshing a back door, they outsource to a new company. For just meshing a side door, they outsource it to a new company. So meshing plays a major role. So here we would concentrate a lot about the meshing opportunity, and then we start doing the simulations also.
Exactly. So guys, this is not only, so one of the things that I wanted to kind of look into this video is this is not only for design masters, right? We are at the end of the day building a whole car, right? And if you build a whole car, you need CFD simulations, FEA simulations, EV simulations, everything to go on, right? So what we are doing out here is providing you an opportunity to work on a real life project where you end up building a full-fledged car, right? If you're looking at a CAE master's program and if you want to get into the meshing aspect of it or doing crash test, then this particular car, you will basically do part level and vehicle level simulations. If you're looking into computational fluid dynamics, then you will basically look into aerodynamics, wind tunnel testing, understanding drag coefficients, and so on. If you're looking into, say, electric vehicles, then there is the EV powertrain. For this will have batteries, so you look into battery management system, control system, electric drives, electric motors, and so on. So this particular project from March is full-fledged. So if you are someone who's in, the reason that we are asking you to enroll by this week is to make sure you will have enough time to understand these concepts in the first 3 months of the coursework. 3 to 4 months, if you put in a lot of effort, you will basically understand the fundamentals so that when you get onto the internship, you work on these projects and understand the concepts that you have learned in the coursework, you start implementing that as well. And that's really important because if you do not understand, you cannot work on these projects. Like Subbu cannot extract work out of you if you do not know how to design, right? So Subbu works with interns who have already finished our design master coursework. Subbu works with interns who have gone through wiring harness, who have gone through BIW design, who have gone through LS. So it becomes very easy for Subbu to kind of give requirements as a project manager and get out outputs from you as well. So that's really important.
Yeah, like what Surya told, it is very important that we at least know the basics from the master's course, what we've developed, and then implement what we have learned. What I see here as an important, and that is why it is keeping me connected towards Skill-Lync or Skill-Lync getting connected towards me, is like we always think about students' future. We always think about student who wants to get into a job and start working on real-time projects. We at Skill-Lync, when we give them a project, it is all industry relevant project. For us to proceed in this project one from the BIW to other add-ons, we will follow very strict timelines, which means like you will have to deliver something on this particular day, you will have to deliver it. If you are committed to work for 40 hours a week, you will have to definitely work for 40 hours a week. If you got to present your progress in weekly manner or bi-weekly manner, you will have to do it without any stoppage. So at the end of the day, we get those students ready to be in the industry already. So you don't have to take that 1 year of GET period or 6 months of GET period after you get into an OEM industry and then show your talent. You can already start exhibiting your talent from the day when you enter the industry, and which is what the company needs now. Now everybody is moving really quick. It is always easy for people to pluck the apples which is very close to us. See, I always believe in this story. There is a tree and full of apples. There are some apples which could be easily plucked. There are some apples for which you need a little more strain, and there are some apples you take a lot of strain, so you ignore those apples. And we are the apples there. You get yourself knowledge by all these kind of information, you will be easily plucked by the industry. You have some knowledge, it takes little time. You don't have any knowledge, you become that ignored apple of a tree. So we at Skill-Lync don't want any of our students to be that ignored apple. So we wanted our students to be the easily pluckable apple, and that is why we try preparing these kind of projects with strict deadlines, because developing one complete car with all these commodities on a OEM industry would take up to 2.5 to 3 years. The design phase itself will be minimum of 2 years for us to develop all these commodities. And that is why we split all these things into 3 2 or 3 different stages. The first stage we've completed the BIW. Second stage is BIW with other levels will be complete. Third stage, parallelly, we'll have powertrain and chassis developed, and also the meshing, the simulation things will start. So we planned in such a way that by end of at least a year, we'll have all the commodities completed and we have the complete information. Everything you work on one single model. It is not like a hood from another car, roof from another car, and engine from another car, and powertrain from another car. No, it is not that. You work everything for one car, so you know the complete basics. You know the complete information. When I say basics here, the basics itself is too heavy.
Exactly. Right? And just to kind of make sure, all of this are paid internships, right? You basically get paid for doing this. These are not unpaid internships. These are paid internships. And the most important thing is we are going to build this car that you are going to design. So what do I mean by that? Well, it is going to be manufactured by Skill-Lync, say at the beginning of 2022. So when you basically apply for jobs, you can basically explain that you have worked on a real car. So that's really, really important, right? So yeah, Subbu, can you go to the next slide and explain what are the other things?
Yeah.
So as Subbu goes to the next slide, one of the things that I will explain is while we spoke about these internships, other important aspect of it is also the ability to work in an environment where timelines are met. So that is what industries look for. So not only the technical knowledge, but also your ability to work on a stricter deadlines. So, right, if you basically go and explain to them, hey, this is the project that I did, this is the amount of work that I spent, and this is the output, you are for sure going to get recruited at any company that is looking for these kind of opportunities. So yeah, go ahead, Subbu.
And I would like to just add another point here. So since we are going to be a very small team, and so 14, 15 people is comparatively a smaller team when we compare it with a bigger level OEM. The biggest advantage of being this small team is that you come to know, even though you work only on one commodity, you come to know the aspects of all the commodities. You would have designed a back door, but you might also know what rear bumper does, what body side does, and what your rear floor does, which is a very big advantage. Right. So if at all a rear floor guy faces a problem, you will be really eligible to go and support him in solving the concerns. Right. And we are doing, and this is what I wanted to actually add to it. So when we are the small team of 15, 16 people, it is going to be really a very big exposure for each and every one among these 15 people. And this exposure is towards the complete car. You won't even get this exposure when you get into an industry. And the advantage of this is when you get the complete exposure, you will know where your interest is, where you can shine much better. And that is the factor what you can take to your interview. You now learned the engineering aspects of all the commodities, but you might be strong on one particular level, which you can express as your interest during your interview processes. And that is what is very important, I feel. So when there is 15, 20 items you have worked on, you will definitely be thorough enough in at least 2 or 3 items, which is sufficient for you to showcase in the interview and explain your competency and get selected for the job. So finally, like I always told, it is very important that we work to get you placed on an OEM or a Tier 1, Tier 2 industry where you do engineering related job. So this, at the end of this 3 or 4 months on, I could definitely say you would be equivalent to a person who had worked in the industry for at least 3 to 4 years. Exactly. So you would be working on a project which is quite similar to the people who had worked for 2 to 3 years or 3 to 4 years. That is there for sure.
That's really, really helpful for you guys, right? So that's why we recommend taking up these courses as well. Not only because you end up learning a lot. So a lot of what Subbu showed in the CAD model is basically taught in the coursework, and the internship basically allows you to build and be a part of a real life car, right? So that's one aspect of it. And what you see in this particular slide is the whole aspect of it. We start with BIW, go to interior and exterior plastics. Again, relook at styling, seats, lights, add-ons, harness the complete vehicle, then go on to simulations where you kind of mesh and also do the simulations. You check the instrument panel and console, then you look into production methodologies. So a few courses in production is coming up in the next quarter of 2021. So we will look into that as well. Powertrain, chassis, and EV engine powered, EV or engine powered. This is basically for our hybrid electric vehicle students to kind of work on that aspect of it. Then you end up working on a prototype and build the whole car itself. So this is the entire project. While this is a long video, what I'm going to do is I'm going to kind of finish it off here. I would definitely recommend you guys to kind of take a look at this video, understand the amount of work that you will be doing. And I also want to reiterate, these kind of projects is not available pretty much anywhere in the, I would say anywhere in the world. There is no training platform which provides any of these things anywhere in the world. I can for sure say that. So would it be fair if I basically said this experience will not be available anywhere in the world?
Of course, we, I mean, I am still in the industry and I haven't got this kind of exposure since my university days till my present situation. So if I got to get this kind of exposure, I should have worked in a company for at least 3-4 years. And there were times, I think you might also remember, there were times when I used to say people stay in a company for 3 years so you at least know the basics of the company. And now if a person is going to take up this kind of opportunity, he will be equivalent to a person who is 2 or 3 years of experience, who is having 2 or 3 years of experience.
Great.
And having number of years of experience is not very important, sir. Doing the right thing during that time is what is very important. That is what is making you sellable in the market, making you that pickable apple, what I told you.
Great. Thank you so much, Subbu, for taking time and doing this. We look forward to working with you. And there are 14 other students. If 4 students can build the whole BIW, I cannot imagine what 14 students will be able to do over the next 4 months. So I am really excited to see this. I want to see this car in the roads in the next year. So
and I can already give you a heads up that we've been looking for prototype sourcing outside India. So it is going to be an abroad project getting involved with Skill-Lync. Yeah.
Great. Thank you so much, Subbu. Thanks for taking time. And
thanks a lot, Surya. Thanks a lot, Surya.
Pleasure as always speaking to you. Thank you.
Thanks a lot, Surya.